According to NEC 400.7a, flexible cords and cables are permitted only for specific uses. These include pendants, wiring of luminaires or fixtures, connection of portable lamps, portable and mobile signs or appliances, elevator cables, wiring of cranes and hoists, connection of utilization equipment to facilitate frequent interchange, prevention of the transmission of noise or vibration, appliances where the fastening means and mechanical connections are specifically designed to permit ready removal for maintenance and repair, and the appliance is intended or identified for flexible cord connection. Data processing cables as permitted by 645.5, connection of moving parts, and temporary wiring as permitted in 527.4b and 527.4c. It is crucial to understand the limitations and stipulations associated with each of these permitted uses. NEC 527.4b addresses temporary wiring and stipulates that such wiring must be removed immediately upon completion of the construction or renovation project. This means that the wiring cannot remain in place indefinitely. It is intended for short-term use during a specific phase of work. NEC 527.4c further clarifies the duration of permissible temporary wiring, stating that it is allowed for a period not exceeding 90 days for testing and experimental purposes. This provision is specifically designed for situations where electrical systems or equipment are being evaluated or tested, and the wiring is not intended to be a permanent installation. If wiring remains in place beyond the completion of the project or exceeds the 90-day limit for testing and experimental purposes, it transitions from temporary to permanent wiring. This transition necessitates full compliance with all requirements applicable to permanent wiring installations, which are typically more stringent than those for temporary wiring. NEC 400.7b elaborates on the requirements for flexible cords used to connect utilization equipment to facilitate frequent interchange. It mandates that each flexible cord must be equipped with an attachment plug and be energized from a receptacle outlet. This provision is intended to ensure that equipment can be easily connected and disconnected for maintenance, repair, or replacement without requiring hard wiring, while also maintaining electrical safety. The requirement for a receptacle outlet ensures that the connection point is properly rated for the intended use and provides a secure and reliable electrical connection. Now consider a scenario where wiring is hardwired at a junction box, often referred to as a J-box, with a plug at the end. This configuration typically does not comply with NEC requirements for permanent wiring. The NEC prioritizes safety and proper installation methods, and hardwiring flexible cords in this manner can create potential hazards such as improper strain relief, exposed conductors, and the risk of damage to the cord. To achieve compliance with the NEC, it is generally necessary to install a receptacle in the J-box. This receptacle serves as the designated connection point for the flexible cord, allowing for a safe and code-compliant installation. The flexible cord should then be equipped with an attachment plug that is properly matched to the receptacle. The proper selection of the receptacle and plug is essential to ensure compatibility and adherence to safety standards. Receptacles and plugs are available in various configurations, voltage ratings, and amperage capacities, and it is crucial to choose the appropriate type for the specific application. For example, if the equipment requires a 208-volt connection, the receptacle and plug must be rated for 208 volts and have the correct configuration to prevent accidental connection to a lower voltage circuit. Similarly, the amperage rating of the receptacle and plug must be sufficient to handle the maximum current drawn by the equipment. Overloading a receptacle or plug can lead to overheating, damage, and potentially hazardous situations. Furthermore, the installation of the receptacle in the J-box must adhere to all applicable electrical codes and standards. This includes proper wiring methods, grounding, and securing the receptacle to the J-box. It is also essential to ensure that the J-box is properly sized to accommodate the receptacle and all associated wiring. Selecting the appropriate type and size of flexible cord is equally important. The cord must be rated for the intended use and environment, considering factors such as voltage, amperage, temperature, and exposure to chemicals or abrasion. Different types of flexible cords are available, each with specific characteristics and applications. For example, Type SO code is commonly used for general-purpose applications, while Type SGO code is suitable for lighter-duty applications. Type S code is designed for heavy-duty applications and can withstand more demanding conditions. The gauge of the conductors within the flexible cord must also be sufficient to handle the maximum current drawn by the equipment. Using an undersized cord can lead to voltage drop, overheating, and potentially hazardous situations. In addition to the electrical requirements, it is important to consider the mechanical aspects of the flexible cord installation. Proper strain relief must be provided at both ends of the cord to prevent stress on the conductors and terminations. Strain relief can be achieved using cord grips, cable clamps, or other approved methods. The cord should also be protected from physical damage such as abrasion, crushing, or kinking. This can be accomplished by routing the cord in a protected location or using a flexible conduit or sleeve. Regular inspection and maintenance of flexible cords are essential to ensure their continued safe operation. Cords should be inspected for signs of damage such as cuts, abrasions, or exposed conductors. Damaged cords should be replaced immediately to prevent electrical hazards. The connections at the receptacle and plug should also be inspected regularly to ensure that they are tight and free from corrosion. Loose or corroded connections can lead to overheating and equipment malfunction. Moreover, it is important to educate personnel about the proper use and care of flexible cords. Training should cover topics such as avoiding overloading cords, preventing physical damage, and recognizing signs of potential hazards. By following these guidelines, you can ensure that flexible cords are used safely and in compliance with the NEC, minimizing the risk of electrical hazards and ensuring the reliable operation of equipment. So to reiterate, firstly, flexible cords are only permitted for specific uses outlined in NEC 400.7a. Secondly, temporary wiring must be removed promptly as per NEC 527.4b and 527.4c. Thirdly, utilization equipment connected with flexible cords requires an attachment plug and receptacle outlet as mandated by NEC 400.7b. Fourthly, hardwiring flexible cords at the J-box with a plug at the end generally violates NEC requirements. Fifthly, compliance typically involves installing a receptacle in the J-box for safe connection. Sixthly, proper receptacle and plug selection is essential for compatibility and safety. Seventhly, cord selection must consider voltage, amperage, temperature, and environmental factors. Eighthly, strain relief and protection from physical damage are vital for cord longevity and safety. Ninthly, regular inspection and maintenance prevent electrical hazards. Finally, personnel education ensures safe usage and hazard awareness. In essence, using flexible cords requires a thorough understanding of the NEC and careful adherence to its guidelines.